First, let's recall how to label the sides of a triangle as opposite, adjacent, and hypotenuse. Before we can label the sides of the triangle, we have to determine what's our reference angle. What angle are we going to say it's the sine of, or the cosine of, or tangent of? In this example, we'll consider the highlighted purple angle as our reference angle, and I'll just call it x. So then the opposite side to angle x is the side directly opposite it. Next, the adjacent side is the side that's not only next to x, but it's a leg of the right triangle. So it's this side right here. We could also recognize it because it's going to be in between the right angle here in green and our reference angle, that purple angle. Lastly, the hypotenuse is always the side that's opposite the right angle. Which trig ratio of x is equal to the opposite over the adjacent? This is the type of question that we'll be seeing in this objective. Rather than asking what is the sine of x, we'll have to take the ratio and figure out which trig ratio it belongs to. We are given opposite over adjacent, and then we know that opposite over adjacent is equal to the tangent. However, we aren't done yet. We have to make sure that we include our reference angle. It's not just equal to the tangent, it's equal to the tangent of our reference angle, which in this example is x. Now let's try an example where we have numbers for the side lengths. We want to know which trig ratio of theta, where theta is our reference angle, is equal to the fraction 5 over 13. First, we have to label our triangle in relation to our reference angle theta. When we label it, we want to know what's the opposite, what's the adjacent, and what's the hypotenuse. We know for every right triangle, the hypotenuse is the side opposite the right angle. Now we know that the opposite side is opposite our reference angle, in this case theta. Lastly, for our adjacent side, that's the side that's a leg and it's next to our reference angle. We also can recognize it because it's in between the right angle and our reference angle. Based on our labeling, we know that 5 over 13 is the same as opposite over hypotenuse. And from our last objective, we know that the opposite over the hypotenuse is equal to sine of our reference angle, which in this example is theta. Therefore, 5 over 13 is equal to sine of theta. Let's do another example. This problem's a little bit different. If we look closely, we'll see that our ratio we're given is 3 over 4, but then on our triangle, we only have the side lengths of 9, 12, and 15. We don't have anything that's a side length of 3 or a side length of 4. So where does the 3 and the 4 come from in this triangle? If we remember back to some examples we did in the last objective, when we found the trig ratios, we had to reduce them if we could. So if we had a fraction like 6 over 8, we would have to reduce it to 3 over 4. So in this case, if our trig ratio isn't directly equal to 3 over 4, 3 over 4 must be the reduced form of the trig ratio. So we know that 3 over 4 must be equal to some ratio of these sides. It could be equal to either 9 over 15, 12 over 15, or 9 over 12. So if we look at each of these reduced, we should find whichever one is equal to 3 over 4. So if we reduce 9 over 15, we can reduce both of them by 3, so we get 3 over 5. If we reduce 12 over 15, we will get 4 over 5. And if we were to reduce 9 over 12, we would get 3 over 4. And that's exactly what we want to see over here. So that means 3 over 4 is the same as 9 over 12, which we can see in our triangle. The next thing we need to know is what kind of side is 9 and 12? Are they the opposite, adjacent, or hypotenuse? So we'll have to highlight our reference angle here, which is beta, and write down which is the opposite, adjacent, and hypotenuse in our diagram. We know that the opposite is the side that's opposite the angle, so 9 is the opposite. We know that the hypotenuse is always opposite the right angle, which is over where 15 is. And then lastly, the adjacent, which is always between the right angle and the reference angle, as well as it's directly next to our reference angle, is 12. So that means that 9 over 12 is equal to the opposite over the adjacent. From there, we know that opposite over adjacent is the same as tangent of the reference angle, which in this case is beta. Therefore, our final answer to which trig ratio of beta is equal to 3 over 4 is tangent of beta, which we would write out as 3 over 4 is equal to tangent of beta. Good luck on the rest of your problems.